Dimensional analysis is also called the unit factor method. Okay? It's a way of taking information, the given information, and usually the given information is in terms of a question that's being asked. Taking that information, going through a series of operations, and coming up with an answer. Okay? The key to dimensional analysis really is the operation. Okay? If you can understand how to do the operation, then dimensional analysis is a breeze. Okay? Take for example, suppose you're visiting a foreign country. Let's say you're going to India, and they speak Indian there, I guess. No, they're actually, well, they're colonized by the British, so they speak English very well. But suppose you go to a foreign country and they don't speak English and you don't speak their language, and you want to communicate with them. How best can you get your ideas across so that you can achieve your goal? Suppose your goal is to go to a certain store, for example, and you're talking to a local native there. What would be a handy thing to have in order to communicate with these natives? A translator, exactly, a dictionary. Okay? And that's the heart of dimensional analysis. The heart of dimensional analysis, the operation, is the translator. The translator will take the given information, translate it, and will give you your answer. Let's take, for example, the following. I know that the currency exchange rate with the Europeans these days is about $1.98 is equal to 1 euro. Okay? 1 euro. So if you go to Europe and you go shopping there, it's going to be expensive. Okay? In fact, Europeans want to come to America and spend their money because it's a lot less expensive. So that's the exchange rate between the euro and the dollar. Suppose a cab fare is about $25. How much will that cost in euro? Okay? What do you think? How should we do that problem? What's the price in euro? 12.5? So we say it's about 12.5 euro. Okay? How did we do that? You guys, even though you didn't know it, actually did dimensional analysis. Okay? And let me try and explain to you exactly the steps that you did, even though it didn't seem like you did that step. First of all, you know that the given information in this problem is $25. So that's the given information. The next step is you use a translator, and the translator is the currency exchange rate. And you know that in the market, it's 198 is equal to 1 euro. So what you did was you took 198 down here, and you took 1 euro up here, and you did the math. And when you did the math, you took 25 and essentially divided it by 2. Okay, because that's what 198 is. But let me just do the math real quick. That comes out to 12.623. 26, or approximately 12.63 euros. Right, cents. Not using this symbol. 12 euros and 63. Whatever they call cents in euro, okay? 12.63 euros. And if you take a look at what we just did, we did basically this operation right here. We were given certain information. We were given $25. We were asked to find how much is it in euros, and we did an operation. And the operation is the conversion factor. That's the heart of dimensional analysis. If you understand conversion factors and how to use conversion factors, then you can easily do dimensional analysis. Before I do that, let me tell you why this method works. Okay? The basic idea. The basic idea of dimensional analysis is that if you take a number and you multiply by 1, what's your answer? Not 1, but the number, right? Anything multiplied by 1 is going to be that number. Okay? If you take that number and you multiply by 1 over 1, isn't that the same as 1? Right? So that's that number. Well, it just so happens that 1 over 1 can be defined in many ways. For example, 1 pair is equal to how many? 2. Okay, so you can say 1 pair is equal to 2. How about 1 dozen? Equals 12. Okay, so if you put 1 dozen over 12, isn't that just 1? So that's a legitimate conversion factor. Anything that's related to each other and are equal to each other for that situation is your conversion factor, is your translator. In our previous example, we said that the conversion factor for the euro was $1.98 is equal to 1 euro. And that's an equality for today. Tomorrow it may change, but for this instant, that's an equality that you can use. Okay? And so that really is what you want to work with in dimensional analysis, because in dimensional analysis, if you take 144 eggs, and I want to figure out how many dozen that many eggs are, then you guys know that it takes 12 eggs to equal 1 dozen. And again, you can see that using the operation, this comes out to 12 dozen. The other thing you want to remember in dimensional analysis is that you always want to be consistent with the unit. You notice I have eggs here. In your translator, that unit always goes into the denominator of your conversion factor. It always goes into the denominator of your conversion factor. If you have a number like, let's say we have 45 miles in 1 hour, and I want to convert that to minutes per hour, then you can see that you need to, sorry, not minutes per hour, but feet per hour. Okay, I'm just converting the miles unit to feet unit. Then what conversion factor will I need to do that operation? Feet and miles, exactly. It just so happens that there are 5280 feet in 1 mile. So the way you do dimensional analysis is you multiply it by a conversion factor. And I always like to start off with just a line, because it's going to have a numerator and a denominator. I look at this unit, it's in miles, so I know that the unit down here has to be miles. I want to convert it to feet, so I know that the unit up here is going to be feet. I look at my conversion factor, and I know that 5280 goes with the feet, and 1 goes with the mile. Okay? And then I just carry out the math. It would be 45 times 5280. That would be my answer. Suppose I have 45 miles per hour, and I want to convert that to miles per second. How would I make that conversion? What relationship will I need to do that operation? What units do you think I'm going to have to work with? 60, but more specifically hours to seconds, right? Now, I don't know off the top of my head how many seconds are in an hour, but I do know that there are 60 minutes in 1 hour, and I do know that there are 60 seconds in 1 minute. So rather than go the direct way of converting hours to second, I'm going to take 2 steps to do this operation. So I'm going to use 2 conversion factors to do this operation. So the first conversion factor will take me from hours to minutes. The second conversion factor will take me from minutes to seconds. So this is my first conversion factor, this is my second conversion factor, and hopefully that'll give me the answer. Okay? You see where hours is located here? It's in the bottom, right? So where do I want to put hours? Do I want to put hours down here, or do I want to put hours up here? On top, because only when it's on top can it cancel. Okay? That's the magic of dimensional analysis. The units will walk you through the problem. You've got hours here, and then you can see over here in my conversion factor, this is my first conversion factor. 1 hour, 60 minutes. So I'll put minutes down here. I'm not even going to put the number in, because the number is not important at this point. It's just the setting up of the problem. Then I see that minutes is down here. So where do I put minutes in my next conversion factor? On the top or the bottom? Top. And then I can see in my second conversion factor, it's down here. And I know that minute and seconds are related. And then I just put in the numbers. I know that 1 hour has 60 minutes, and I know that 1 hour has 60 minutes, and 1 minute has 60 seconds. And then I can carry out the math. That is the heart of dimensional analysis. You let the units walk you through the problem to give you an equation to solve the problem, and you let the operation work out the problem so that in each step, the translators, you're multiplying by an equality. You're multiplying by 1. 60 minutes is 1 hour. That's nothing more than 1. 60 seconds is 1 minute. That's nothing more than 1. What we're doing is just translating the units here to a desired unit that we're trying to achieve. Now, when you do this in your calculator, let me give you another trick that you can use. Wherever you see 1, you want to skip that step. Because when you multiply a number by 1, it's just that number. When you divide a number by 1, it's just that number. So skip those steps and go directly to the heart of the operation. What you want to do in your calculator is punch in 45, divided by 60, and divided by 60. And you should get your answer. Okay? Don't hit equal, just take 45, divided by 60, and divided by 60 again. And in the end, what you should get is the following. My calculator works. Okay? 45. You should get 0.0125. Miles per second. Now, how many significant figures should this answer contain? 2. So how should I round this off? 1.3 times 10 to the negative 2, or I could also write 0.013 miles per second. But 1.3 times 10 to the negative 2 certainly would be acceptable. Okay? So let me try one more difficult problem. And let's see if you guys can figure this out. I want to buy gold. Okay, gold is always good because everybody's ears always perk up when we talk about money. So I like to use that example a lot. And let's say that the following information is provided. The yen, there's about 138 yens. I don't know how you do the yen symbol. Let's just say that's the symbol for yen, is equal to $1. Okay? If gold at the Tokyo Exchange is gold costs 48,234 yens, okay, per ounce. And I want to purchase 5 grams. How much will that cost? Okay. In dollars. How much in dollars? So the price of gold, we have 1 ounce, 1 OZ, and that's an exact number, by the way. We have 1 ounce, that's an exact number, and it costs 48,234 yen. And I want to know if I want to purchase 5 grams, how much is that in dollars? No, 48,234. Yes, is equal to 1 ounce of gold. Now, this looks like a complicated problem. Okay, it's got a lot of parts, and all the information is not provided. The information that you have that you want to start out with is 5 grams, because that's not a conversion factor. That's just given information, the mass of gold. The rest of these are actually conversion factors. There are 48,234 yen per ounce of gold. There are $1.38 or 138 yen per dollar. We also need to convert ounce to grams. We need that conversion factor because it's not readily available. Okay, so this will require you to use the following information. There are 453.9 grams in 1 pound, and there are 16 ounces in 1 pound. Now, this is a problem that is probably a little bit difficult in terms of the parts that you have, but it's a good problem in terms of using dimensional analysis to come up with an answer without knowing the equation. I don't know what equation to use for this problem, but through dimensional analysis, I'm going to find the answer. So, the way I want to begin my problem is I want to start out with 5 grams of gold. In the answer, I want to come up with dollars. The information that I have is that it's going to cost 48,234 yens per ounce. So you can see right away that I've got grams here. I somehow have to convert that over to ounce. Okay? So the first series of conversion factors that I'm going to do is convert grams to ounce. How would I do that? What would I use? What information can I use to do that? You know that there's grams here, so my first conversion factor better have grams in the bottom. Okay? Grams in the bottom. What conversion factor over here has grams? I could, but if I don't have that readily, then I would need to do that few steps. Okay, and I want to show you that if you don't have that conversion exactly or directly, then you can take 2 steps to get to the same place. Okay, but that's a very good point. Look over here. Okay, there are 453.9 grams in 1 pound. So that's the first thing I want to do. I want to convert grams to pounds, and then I can convert pounds to ounce. You see how I have pounds over here? I better put pounds down here. I put ounce up here. Those 2 steps right there will take me from grams of gold to ounces of gold. Now, how do I convert? What conversion factor up here relates ounces of gold to monetary amount? Look up here in the information. 48,234 yen is equal to 1 ounce. So you see how we have ounce over here? Well, we better put ounce down here in my next conversion factor, and yen up here. Okay? I would be using this conversion factor right here. Now finally, I want to convert yen to dollars. What conversion factor would I use there? Exactly. You can see that if yen is up here, yen better be in the bottom in the next conversion factor. And I can see from the information that yen is related to dollars by 138. But before I put in the numbers, I just want to show you that we came up with the equation just using the units. Just using the units. We set it up so that we can solve the problem. The grams follows down here. The pounds follows down here. The ounce, the yen, and at the end we come up with dollars. Where do we put the numbers? Well, the numbers are going to be placed based on the conversion factors that we have. We have 453.9 grams is 1 pound, so that's what we want to put down here. 453.9 grams is 1 pound. Okay? We know that there are 16 ounces in 1 pound. We know that there are 48,234 yen in 1 ounce of gold. And finally, we know that there are $138 or $1, 138 yens in $1. And it's just a matter of crunching through the calculations. So in this particular problem, let's figure out if this is a reasonable number. Okay. We do the math. Again, wherever there's 1, you skip and just go directly to the calculation. You punch in 5 in your calculator, you divide by 453.9, you multiply by 16, you multiply by 48,234, and you divide by 138. And I come up with $61.60. $61.60. How much is 5 grams of gold? 5 grams of gold, you guys will discover today, is about the mass of 2 pennies. Okay? A penny is about 2.5 grams. So 2 pennies is about 5 grams. Not very much. Pretty expensive. Okay? That's a pretty expensive piece for 5 grams. So that's the heart of dimensional analysis. When you guys work on this problem set for next week, remember to use this technique and practice it well, know it well, because it'll pay dividends when you come to chapter 8 and chapter 7. It's a very simple technique, but you have to master it at this level. Question?
Do you want us to do it that way in a test? Because like when I learned it, multiply on the top, not total divided by the whole bottom.
It doesn't matter. Whichever you're comfortable with, the bottom line is you get the right answer. Okay? You get the right answer, I don't really care how you work it out. Okay? But yeah, you can certainly multiply the top and then divide by the bottom. That's fine. I just like to go through it this way, the order of operation, and skipping the multiplication by 1 or dividing by 1 because it'll save you time. Okay? So that'll be due next week. Okay? And there's one challenging problem, number E. And number E in this particular problem set, this is found on page 17. You can see it involves the speed of light, and it involves converting minutes to seconds. But it's as easy as this problem if you set it up correctly. It's not difficult at all. Okay? So, question?
How about significant numbers?
Significant numbers are always based on the data that you actually use. You see how you have, good question? You see how this is a conversion factor? You see how this really is a conversion factor? These are conversion factors. Conversion factors are definitions. And because they're definitions, they have infinite number of significant figures. This thing has 48,234 is equal to 1.000000 ounce. Infinite number of significant figures. So when you round off your final answer, all of these are conversions. They don't limit the number of significant figures your answers contain. It always goes back to the raw data. You started out with 5 grams. You could have got 5.5 grams. You could have had 5.3 grams. Well, in this particular case, we're using 2 significant figures, so yes, it would be rounded off to $62. Thank you. Okay, 2 significant figures. And in this particular case, what you guys are doing is figuring out how many pennies it'll take to reach the sun, from the sun to Earth, based on the fact that light travels at 3 times 10 to the 8 meters per second, or in this particular case, I give you 186,282 miles per second. I won't answer that question, but I will certainly help set it up. Okay? The first thing that you want to do for this particular problem is always start with the information that you have, the given information, the goal, and then the conversion factors that you need. So the given information for this particular problem is you've got 1 penny, and the diameter of that 1 penny is 2 centimeters. So that's a conversion factor. 2.0 centimeters is 1 penny. Okay? That takes you from penny to length. The second conversion factor is travels at 186,282 miles per second. 186,282 miles equals 1 second. That's a conversion factor. Speed is a conversion factor that relates distance to time. If you write it as 186,282 miles equals 1 second, then you can use that as a conversion factor. Information that you need to do is convert time to distance, or in this particular case, pennies. But pennies is related to distance by this conversion factor. 2 centimeters equals 1 penny. Okay, so that's how we get pennies in this particular problem. Time. You can see that time is found in this conversion factor. Okay, so we can certainly see that time and miles are related. And then in this conversion factor, we can see miles, which is the length related to centimeters. So we need a conversion factor that will take us from miles to centimeters. We can do 5280 feet equals 1 mile. And we can say that 1 foot equals 12 inches. And finally, we can say 2.54 centimeters equals 1 inch. If you have a more direct conversion factor, like 3.0 times 10 to the 8 meters per second, you could use that too. Okay? As long as you have that information. That wasn't provided in the problem. I wanted you to work with miles per second, but if you knew this, you could have worked with that. So, let's figure out a strategy. We can go from time to length and then from length to pennies. That's how we're going to do this. Okay? Now, what time do we start with? 8 minutes and 30 seconds. Okay, so the time that we have is 8 minutes and 30 seconds. Now the problem with this is that these are not the same units. So you have to either get it all in minutes or all in seconds. It's probably easier to get it in seconds because we have seconds here. Okay? So we know that 8 times 60 is going to give us how many seconds for the 8 minutes time? And that would be what? 480? And then all we have to do is add that to the 30 seconds, right? And so this comes out to, in this particular case, 510 seconds. Okay? I'm going to carry it out to the 10th of a second because I have 30.0 and I have 8.0. So 8.00. So I'm going to carry it out to the 10th of a second. That's our starting point. The rest is easy. You just slap down a bunch of conversion factors. You start out with 510 minutes. 510 seconds. We multiply that by our first conversion factor. What unit goes in the bottom? Seconds. What unit goes on top? Miles, right? So I will just circle that to show that that is a conversion factor I have already used. And then after that, I will do a second conversion factor. What unit goes on the bottom? Miles. What unit goes on top? Feet. Okay? You see, I'm taking the roundabout way. I'm not going the direct way. I'm going through these conversion factors. But that's okay, because I will still get there. Feet will be at the bottom. What's on top? Inches. Okay, so I've got this and I've got this. Finally, I've got inches here. Right? Centimeters on top. Good. The units will always tell you what order it goes in. Inches needs to be in the bottom, centimeters on top. That's my. And then I'm going to multiply that out. And I'm going to multiply what's in the bottom? Centimeters. And what's on top? Pennies. And that's my answer. All I do is put in the numbers, and I should get my answer. I know that there are, for every 186, 282 miles, I have 1 second. That's the speed of light. For every 5280 feet, I have 1 mile. That's the distance. That's how many feet in the mile. For every 12 inches, I have 1 foot. For every 2.54 centimeters, I have 1 inch. And then finally, for every 2.0 centimeters, I have 1 penny. So if I carry this through, you should be able to calculate how many pennies will stretch between the sun and back based on the speed of light. Okay? Seems like a hard problem in the beginning, but you can see how easy this was set up just based on dimensional analysis. That's why I can't emphasize dimensional analysis enough, because it really does solve a lot of problems. Question?
For 4 significant numbers of 510 seconds.
Yeah.
Is it because you add into it?
Yeah, because I added it, exactly.
What
I have
about the multiplication of 60?
8.00 minutes, and I know that for every 1 minute, I have 60 seconds. So that's going to be 500, that's going to be 480 seconds. Actually, that should be just 3 significant figures. You're right, it should just be 510. That should just be 3 significant figures. Thank you for correcting me. Okay, because when you multiply 8 minutes by 60, this is a conversion factor, you should only get 3 significant figures out of that. And then when you add it to 30.0, even though this is to the 10th of the place, this is only to the 2nd. So at the end, you only get 3 significant figures. That's a good point. The rest of this should be straightforward, I hope. Okay, I will grade it and give it back to you next time. But again, dimensional analysis, very important in chemistry, very important in science. If you know how to do dimensional analysis and you have a lot of word problems, then it'll get you out in a lot of time. I can't emphasize it enough.